In today's video, I'll be explaining how you can save instances on your Roblox games. This can be used for a tycoon system where you save the player's progress, or anything you need to recover an object from a past state. So let's get started. First off, what are we going to be doing? Well, we are going to be doing something called serialization. Serialization is the process of converting an object from a non-savable format to a format that is savable. In programming off of Roblox, you convert an object into a stream of bytes, but however, in our case, we don't have that functionality. So what we are going to be doing is instead converting it from an object to a table. So how might we do that? Well, you might notice that we don't need to actually save everything about an object. If we click on this part over here, do we really need to save every single property? Like say for a tycoon game, what might we want to save? Well, we might want to save the name to identify the object later. We might want to save the color. We might want to save the position, the size, the orientation, and maybe can collide depending on the game. But other than that, do we really need to save anything else? Do we need to save the material? Maybe. Maybe not. Do we need to save, the locked property? Probably not. So instead of saving this entire list here, which would really use up our data fast, for one, and also we just don't need to. So we have to think, do we need this data and do we not? So first off, we're not actually going to be saving the entire instance. What we're actually going to be doing is taking the components we do need and then adding them into a table in a way that can be saved. So as you know, position and C-frames and orientation cannot be saved because this is vector 3, this is the C-frame value. So how do we actually save that? Well, instead of inputting just the C-frame or vector 3, we input the individual values. So the individual coordinates, the individual rotation values, or for color, the individual RGB values. So it's really not that difficult. Before we go any further, we do need to have a parts folder full of parts. As you can see, I have already done this. So I have parts here and they're rotated at different angles. They have different properties and different positions, and I've named them different things. So I'm going to be saving the name, the position, the rotation, and then the can collide property. So let's create a script in ServerScript service. I'm going to rename this to data handler, and I'm also going to be assuming you know how to use DataStores. So with that in mind, let's go ahead and get the player service, the DataStore service, and create a new data store. All right, so next we're gonna get a public key prefix. And so we're gonna get the key prefix. This is gonna be something like player, just like that. And then we're also gonna get the parts folder. So local parts equals workspace dot parts. And then we're gonna create some functions and then signals. Okay, so now under functions, we are gonna create two functions, one to load and one to save. So I'm going to create one function, which is save. It's going to take in a player, which is going to be a player value. This is just type checking. If you want me to do a tutorial on type checking, comment down below and I will consider it. But just know for this video that this just tells me the type of value that this is. It not only makes it clearer to see, but it also helps with typing. So we get things like player.userid getting suggested for us. But anyway, that is that. Then I'm going to create another function called load, which is also going to take a player value, which is going to be the player object. Okay, so now let's call these functions when the player joins and when the player leaves. So to do this, all we have to do is say player.playerAdded connect to a function, but in this case, we just want to load the data. Then when the player leaves, we can say players.playerRemoving connect to save. And just in case that we need to handle this case, we also need to handle when the game closes, when the game binds to close. So to do this, this is if like the game gets shut down, like the servers are shut down or something, but we just say game bind to close, we give it a function, and then we say for I PLR player in I pairs, and then we say players get players. So we're going to get all the players in the game, and that's how I knew that this was going to be a player value all the time. So next, what we can do is call save on that player. Just like that, that's all we have to do. And now it should save all the time, at least if our saving and loading code is properly written. Okay, so next we're going to actually save the data first, so then you can see the format of how we're going to load it in. So to load the data, or to save the data, all we're going to do is get a key variable. So we say local key is equal to, and then key prefix, and then to string player dot user ID, and that'll give us the key. And then after this, we can create a data variable. So we can say local data is equal to an empty table, just like that. And then we can loop through the parts to actually insert the data. So what we can do is say for I obj in I pairs, and actually this obj value is going to be a base part. So it's going to be a base part. Although you can, if you know the type of value you're going to be saving, you can set this to like a model or a base part in my case. But if you don't know, just either don't even do type checking at all or just set it to an instance. But I know mine, so I'm going to do base part. So next, all we have to do is give it the parts table, or the table of all the parts. So we can say parts get children and then do. And now we are going to be looping through all of the parts. So now we just have to insert the data that we want to save. So pretty much we say table.insert, we give it the data table, and we're going to be saving a new table. So for each object, we're going to be getting a table, so then we can easily recover it. There are other ways to do this without using a table, and this can compress our data a bit. However, in our case, we're not worried about that. And if you want to learn about data compression, I'll link a video down in the description, which goes a lot more in detail on data compression. But that's not the focus of this video, so let's just continue. So as I said, I wanted to save the name, the rotation, and the position, and the canCollide property. So to do that, we're going to be saving the name first. So to get the name, all we can do is insert the name. So pretty much all we have to do is just say that we want to insert the obj name. Then we also want to save the obj canCollide property as we want it. Then we can give it the position. So obj.cframe.position.x. And then we just copy and paste this 3 times and change the coordinates to the correct ones. And then we do the same for the rotation. So obj.orientation.x, and then we copy this 3 times and then just change the coordinates. If you're confused about which things like are what, if you want to put some more information, we can comment this and say rotation. If you wanted to kind of split this up a bit, and then position. And that kind of makes it a little bit more readable. But anyway, now this data is saved in the table. I'm pretty sure that's all of it. We have the name, we have the rotation, we have the position, and we have the canCollide property, which is what I wanted to save. So anyway, how do we actually save this? Well, assuming you know DataStores, this should be pretty trivial. But if you don't know, I'm not going to be going over the code, but you just say local success error. And then we're going to be saying repeat until next success error equals pcall function, and then we can just use update async. I'm going to be using update async, but you can use set async as well. But pretty much we just say DataStore update async. We give it the key, and then we give it a function. And then to save the data, all we do is return the data table, and we are going to say task.wait, just so that we don't break our code. Now, when are we going to repeat until? Either until success, and that's pretty much that. And then just as a check, we're going to say if not success, then we are going to warn to the client, or server I mean, that we failed to save data, and then give toString error. And that should be good for saving. And then for our loading, all we pretty much have to do is loop through this data and then assign it to the object that we're doing. So again, obviously we are just going to create a key variable. So that's just going to be key prefix, and then player toString player.userid. And then from there we can just get the data. So local success error, and actually I can do that. And then we can just say that repeat until, actually it automatically does it, until success, or in this case we do have an or, players find first child player.name is not. So if not, there we go. So basically if we succeed or the player is no longer in the game, then we can stop. And then we can just set this data. So data equals, and oh right, we need to create the data variable. So local data, and data is equal to data store get async, and then we give it our key. And that is pretty much that. Oh, right, we need to put this in a p call. So success error p call function. And that should be that. So now all we have to do is say that if we succeed, then, and if we don't, we can just warn that we failed to load data and just give it our error again. But I don't think we will have any errors. But if we do succeed, then all we can do is just loop through this data and create a new part and assign it to the part. So all we have to do is say that for I obj in I pairs data do, and then in here we just create a new part. So we say local new part is equal to instance.new part, and now we can start setting properties. So new part dot, and then we're going to give it the name is equal to, remember, this is the first coordinate. So remember, our data right now should be a list of tables. Since we saved everything in a list of tables, all we have to do is find this table, and then when we get to it, just index these values to get them back. So keeping that in mind, all we have to do is say obj1. That's all we have to do. We just have to index it. And then new part dot can collide is equal to obj2. And I think you can kind of guess where we're going with this for the rest of them too. But pretty much all we have to do is set the position now. So we say new part dot cframe is equal to cframe dot new, and we just give it obj3, obj4, obj5, and then for the rotation, all we can do is just say new part dot cframe times equals, this is the same thing as saying times something, cframe dot angles, and then in here we are going to have to convert our data from degrees to radians. So how do we do that? Well, first off, let's just load in our data. Obj, and then our last value was 5, so we just say 6, obj7, and then obj8. How do we convert these to radians? Well, all we have to do is multiply by math.pi and then divide by 180. So this is pretty much just, this is the formula. We take our degrees multiplied by math.pi and then divide by 180. Let's just copy this. And now that should work. And then to finish off, all we have to do is just say new part dot parent equals workspace. Although there actually is one more thing that we have to do. Since we didn't save that these were anchored, because I'm anchoring these, what I'm going to do is just automatically anchor them. So I'm just going to say new part dot anchored equals true. And actually, since we're creating a new part, the top surface is going to be studs, which we don't want either. So we can say dot top surface equals enum dot surface type dot smooth no outline. And that pretty much should be that. So before we run this, since this code will automatically assume that we have data, all we're going to do is just make a simple if statement saying that if not data, then return. And so this will just automatically halt the code from running if there is no data to load, which is kind of what we want. So let's hit play. All right, so let's load in this data, as you can see. And now let's go ahead and see if it saves. Okay, and hopefully it did. Now let's move these parts into the data handler and let's hit run again. Let's see if they load in, which they do, in the exact same positions. So that is pretty much it. Okay, so I think that is actually pretty much it. So let's just go over the code like I usually do. So first off, we get our services and our data store. Then we get our key prefix and the parts folder. Then we create two functions, one to save and one to load the data. And in the save function, we get our key, then we get a table for our data, we loop through the parts that we want to save, and we insert in this table here what data we want. In this case, the name, can collide, the positions, and the orientation. Then down here, we attempt to save it, and if it saves, it will just save using update async, and if it doesn't, it will warn us that it failed to save. Then in load, we do the inverse of our save function. So we create our key, then we get our variables here, our data variable here. we get the data that was saved, but only if we succeed. Then we check if there's any data in our table, and if there is, then we move on to this. Otherwise, we just don't do anything. We just return. If we do have data and it succeeded getting data, then we loop through the data, we create a new part, we set the name, the canCollide property, the C-frame, and the rotation based on the saved data. Keep in mind, we do have to convert the rotation to radians, but we do that multiplying by pi and dividing by 180 degrees. Then we do that, and we do that for each axis. Then we set any properties that we want to be global to all parts, and then we just parent it to the workspace. However, I actually forgot to set this to the parts folder to save again, and well, now I just made that fix right now. And if we didn't succeed, then we warn to the console that we failed to load data. So that's pretty much that. Obviously, for saving instances, this is a very high-level overview. There's a lot of things you can do to improve this code, but this is just a basic overview. Again, if you want to go into data compression, I will leave a link in the video description to a tutorial that has a detailed video on that. Anyway, thanks for watching. I hope you did enjoy. Make sure you subscribe, like the video, and share it. Join the Discord server if you need any help, and I'll see you in the next video. Thanks for watching.